Hey, this is Kenneth, and today I wanted to do a teardown of one of these Sonoff basic smart switches, which are 10 amp Wi-Fi connected relays that you can control from, either their app or realistically from any sort of web API that you want using your own system. So I got these on Amazon for less than $10 a piece, and so far I've been pretty impressed with them. So in the package you get, it comes in a kind of a surprisingly small box with some paperwork stuff that doesn't matter, bag of screws, and then the device itself, which has two wire covers for your input and your output. So once you put the wire in and close the screw terminals, these have little teeth on them that clamp down and are a little bit of strain relief. So it's conceivable that you could have this in line since it's finger safe. I'm not a big fan of that, but I mean I'm going to do it to begin with. And one thing that I really like about this is that the screws that hold the cover down also hold the whole thing together. And so as it comes right now, it is really easy to just push down on the bottom of the case and the whole thing just comes apart. And so getting access to the internals is really easy, which is great because there's been several third-party firmware images developed for this. The one that I've been playing around with is Tasmota. And so I actually never even bothered powering this up and installing the Sonoff app for it. I immediately opened it, soldered these headers on here, right? So these headers aren't normally here, and loaded Tasmota on it. Loading Tasmota is the same as any other programming an ESP8266 based controller, which is on here. So I think that warrants a separate video. I just want to focus on the hardware more than anything else. But really it comes down to the fact that this 0.1 inch header here has ground, 3.3 volts, transmit and receive for the UART for the ESP8266. And so if you hold down the user button when you power it on, it then goes into bootloader mode, and you can, over the serial port and using using Espressif's ESP tool firmware loader, you can load the Tasmota bin onto it real easy. But main thing is I just wanted to show this. So the cases, comes in 4 pieces plus the screws, and getting access to this is real simple. So let's put this under the microscope and talk about what we're looking at here. And then for my first, Hello World project on it, I'm just going to take a extension cord and splice that into this, which is far from ideal, but is, since I don't expect, I live by myself, and so I'm not going to have any children or anything walking around. I'm willing to splice it in line like that for development purposes. So let's look at this under the microscope and go from there. Looking at the Sonoff under the microscope, let's first focus on the digital low voltage section. The brains of the whole operation is the ESP8266 here, which you'll notice is labeled an ESP8285. And why that is that's because this chip here is an ESP8266 microcontroller with an additional 1 megabyte of SPI flash integrated into the chip. Because if you look at any other Espressif ESP based board that has an actual ESP8266 or an ESP32, you'll notice that it has separate to this a whole discrete SPI flash chip. And so this integrates a minimal amount of flash onto the chip itself so that they don't have to spend board space to lay out that second SOIC8 chip and run the SPI bus between them. So that's why it's an 8285, but you just refer to this to as an 8266 processor. So that's your controller. Here's your user button. This is hooked up so that you can hold this down for bootload on power up, and normally you can use it to toggle so the firmware supports you can just toggle it from here. So this is essentially your local, over, if the whole internet isn't working, you can at least toggle it from there. An indicator LED here. This part here is your output capacitors to your basic PCB antenna. And so this is your Wi-Fi antenna here. These 4 pins are ground, transmit, receive, and 3.3 volts. They're nicely labeled on the bottom, so you don't need to try and remember that. But so those 4 holes are on a 0.1 inch pitch and showed up nice and clean. So it was real easy to just break off 4 pieces of male header, solder that in, and then using a USB to UART adapter, I was able to power the controller from that and load the firmware. The other header that you see up here is essentially gives you the ability to build like a remote control, like a remote front panel for this. So 3.3 volts is 3 volts, ground is ground, and then this keypad here is connected to this button. And so if you wanted to, mount an additional button somewhere else, you can just tack a wire onto that hole and then take it somewhere else. This KP pad is actually this is connected to the user button pin on the controller. And so it's actually kind of interesting, as you'll notice that there's a 0 ohm resistor right here that connects the microcontroller's KP pad to the local button's key pad. And so if you want to disable the local button and pull-up resistor, you can remove that resistor, and then if you would then need to build your own remote button and pull up to 3.3 volts, and the button then would connect you to ground. But you then that means that this resistor here gives you the option to completely disable the button physically on this board, which is pretty convenient. There's also an LED pad, which, as far as I can tell, is not actually connected to the LED down here. This LED comes off of the controller. This LED pad has a missing current limiting resistor to the control line for the relay. And so this isn't the same LED as this, but if you put a current limiting resistor there and then connect an LED from that to ground, the LED would light up whenever the relay is closed, which isn't quite what this 2-color LED down here does. As you'll notice, this actually has three leads on this LED. This one gives you some status blinking and stuff that doesn't correspond to when the relay is blinking, but so that's an option. The bummer about this header, first of all, the bummer is that it comes filled with solder, so you'd have to use some solder braid or a solder sucker to desolder that. And if I take a piece of male header and line this male header up with these pads, you'll notice it doesn't line up. So I guess they were a little bit space constrained, and so these holes look like they're on a 2mm pitch, which is another standard header pitch, but it's not the 0.1 inch pitch that everyone's used to. And so so the easiest thing to do is to just tack some wires straight onto this, but if you want to connectorize it, I think you're going to need to get a piece of 2mm male and female header, or a piece of 2mm male header and some connector or something to go onto that, if you want to connectorize it. But that's pretty much the whole low voltage section. This right here is the control line that runs off to the relay. So this is the actual 10 amp relay that switches it, and the driver for that is on the bottom. And so this is presumably a transistor here that from the controller runs the relay, which is coiled there. There's your flyback diode on the relay. And then this right here is all the 3.3 volt voltage regulation for the low voltage section. But that's it. Now, one thing to notice is that I'm actually really impressed with this board overall. So you'll notice that there are slots cut in the PCB completely separating this whole low voltage section from the high voltage on the input and output. Right? And so if we come back and look at the top and come back over here to this is your input, neutral, and line, you'll notice that the neutral screw terminal comes out this far and it actually has a piece of double insulated wire that has it run all the way to the output neutral here. The input line, so this is your 120 volts AC, this comes out here, goes into the relay, and then the output of the relay goes into another piece of double insulated wire, comes out to here, and then goes to the output line screw terminal. And so I've seen a few people on YouTube talking about these things say that since it's AC, your line and neutral doesn't matter. And I wouldn't really agree with that, since your neutral is unswitched. And so you really do kind of want to get your neutral right here because it's only the line side that goes through the relay and switches. And so if you swap these and you put your line here and your neutral here, it'll still turn your lamp on and off, but I don't really like having the problem with that is that if you switch your neutral line here, it means that the entire lamp will sit at 120 volts AC, which nominally shouldn't matter since an ungrounded lamp should be double insulated and everything. But it means that it's a little bit more dangerous because if someone turns off the lamp and unscrews the light socket, the entire lamp socket is electrically hot. Where if you switch the line and leave the neutral connected, the whole lamp will be at nominally the same voltage as ground. And so, yes, it's AC. It will work if you reverse these two wires on either side, but there's a reason that we make a distinction between line and neutral. Neutral is nominally the same voltage as ground, and line is 120 volts, plus or minus. But yeah, so here's your line in, right? So that goes to the relay. And it also goes to this fuse, which I think it's a 1 amp fuse, and this is a fuse for for this device itself. And so this fuse goes to here, and you'll notice there's again lots of good routed slot track separation, and so the fuse comes along this trace to here. Here is your transient suppression up here, so you got your capacitor and your probably a mauve, I would assume, and then your line and your neutral both come in to this, which is presumably a full bridge rectifier. And so this plus all of this is kind of your real classic switch mode power supply. So your full bridge rectifier, this then is 170, 180 volts DC, which has a 400 volt electrolytic capacitor on it, right? And so that's your input rail. And so you've got 180 volts DC here with then, I believe, there's a molded inductor here, which looks like a resistor, but it's actually, you can see it, L1, right? So there's your molded inductor. And so from right here, you've got pretty well filtered 170, 180 volts DC, which then goes through this, which is your switch mode power supply. So you've got your controller's IC there and a transformer up here. And then on these two output lines, which snake over here, that is your presumably like 5 volts probably. So that's where your 5 volts drop in here, and then that was what runs the rest of the circuit. So on the the relay then runs these two double insulated wires back here, and so the output stage again is very simple as far as it's just the two jumper wires from the other end of the board dropping onto over-tinned wire onto your screw terminals here. If I was to have any complaints about this board in general, it would probably be that I don't I think the specific screw terminals they picked here are a little cheesy. They're the ones that, I don't know if I'm going to be able to get a good shot of this. They're the ones that just have a little metal tab here, and so you shove the wire in and then bend this tab by tightening the screw. I'm not a big fan of that style. I just think it's kind of cheesy, and so if I was to do anything on this, I would probably desolder the input and output line connectors and solder in something a little bit nicer. It's a real standard 0.2 inch spacing between these pins, so it'd be real easy to find replacements for it. And so kind of depending on exactly what you're doing, it might be worth replacing that. But other than that, I mean, like the fact that they have, the routing is, separating all the high voltage stuff, I'm really impressed with that. I like it. The fact that they give you, 2 headers to talk to the microcontroller UART and all of the I/O, like the button and a line off of the relay here, makes this a real hacker-friendly board, which is probably part of the reason why these Sonoffs have gotten so popular. And then the fact that like they put a 0 ohm resistor here so you can disable the button, I think is nice. But yeah, so that's kind of the tour of the board. So I want to show kind of what I'm going to do in my first one now, which is going to be just put an extension cord on it. But other than that, let's move on. So at this point, presumably, so I'm assuming that you have watched a different video as far as the, put on a piece of 0.1 inch header and load whatever firmware you want on it, or I mean, even you use the stock firmware. I mean, I'm not gonna tell you what to do. I'm not your boss. I'll just point out I never even touched the stock firmware since Tasmota seemed much more interesting to me. And so as it comes like this, you've got the input and output terminals here, and you've got the user button. So I walked over to the hardware store and bought a 16 gauge two prong extension cord. And so we are going to open this up and then put that into, here is the safety tag that we're about to disregard. And so I think that in a 6-foot extension cord, I'm going to want this control thing kind of more towards the outlet side. And then again, you can put this anywhere you want in here. And so again, we're very much making sure that this is unplugged. And when you're looking at this plug, to identify which side is line and which side is neutral. So if we take, so here's a standard NEMA 515 duplex outlet. So this is, your normal household residential plug in the US. The large hole there, that's your ground. Then the larger slot is your neutral, and the smaller slot is your line. And the way that I remember that is that the one that is bigger is easier to shove metal bits into, and so that's the one that you want to have 0 volts on. Now granted, you can't rely on that. People often get that wrong when wiring residential wiring, but that's what it's supposed to be. So that's supposed to be your neutral, and that is your line. And so when you look on the cord, you'll see that there's a larger prong and a smaller prong. The larger prong is your neutral, and the smaller prong is your line. And so looking at the zip cord itself, you will often notice that one of the 2 sides actually has a ribbing on it, and so it's relatively easy to keep track along the whole length of the extension cord which wire in this is which. And so in this case, we can see that there's ribbing on this side, and that ribbing is on the neutral. And so I know that when I come down to about here and whack this cable in half, that on both sides of it, I can feel that there's rib on one of the 2 conductors, and that is my neutral. And so when I'm mounting that in here, I want to make sure that I put that in the upper screw terminal. So at this point, we'll take our wire cutters and separate these two conductors a little bit. I also like to use like a box cutter or an X-Acto knife sometimes to cut this, but it's personal preference. So you want to separate the two wires, and so with the zip cord, it's designed so that you can pull it apart. And what I like to do is pull it far enough apart that I can then cut off the original part that I cut onto, because that cutting action into the web in the middle here likely nicked one of the insulations or the other. And so I'm going to go down to right below where I originally used it and cut it flush again. And so now I've got a nicely separated line and neutral with no damage or scarring on the insulation. Now we take a pair of wire cutters, which, let's see. Most people, their first pair of wire cutters are these combination everything wire strippers, crimpers, bolt cutters, blah, blah, blah. I hate these in pretty much every way possible. So I would definitely recommend that you get a better wire stripper than that. The one that I use the most often is a specifically dedicated wire stripper like this. But I also am quite a fan of these automatic ones, which take a little bit more finesse and technique, but they actually have a set of knives that drop down and grab the wire, and it's a whole thing. But for this, we'll just use this one. So we are stripping stranded 16 gauge, and so the holes will nominally be labeled. And the trick here is that we need to take off actually a relatively small amount of insulation, since these screw terminals aren't very deep, and we want to definitely have insulation grabbed by the little strain relief teeth inside the Sonoff Basic. And so I am really pulling off like maybe 7 or 8 millimeters of insulation, and we're going to see how that does in these screw terminals. Ooh. So I was real careful as I was digging in on this that I didn't damage the actual copper conductors at all. If I had, I would have cut it off and zipped it out a little bit more and started over. And so again, I'm remembering that my larger blade here, which is my neutral, has the ribbing on it, so I can tell which one's here. If I didn't have that, I could take my multimeter and put it in like tone out mode. And so at this point, my multimeter is in tone out mode, and I could actually tone this out as well, right? So I could put one blade there and then double check that, yeah, the ribbed side is in fact the neutral, right? So this is our input, since we've got the plug. So looking at the Sonoff itself, we are going to want to put these into the input side. And I've got a little flathead screwdriver that matches the size of the slot screw. So I just need to real carefully feed those in without getting any loose danglies floating around out here. And this is kind of the hardest part, kind of getting both of them in without everything going sideways on you. So I'm making sure that the screw terminal is all the way open. Really got to make sure that these two wires are really parallel and at the right spacing, so they both just want to go right into their corresponding screw terminals, and then I can tighten it up. So we're going for very firmly finger tight here. You don't want to over torque it, of course, but all right. So you definitely don't want to risk breaking the screw terminals. But I want you to notice really how cleanly we have that placed. the insulation comes practically up to the screw terminal, but definitely isn't getting stuck, captured into the screw terminal, right? And so I was able to push these wires all the way in, and they bottomed out on the back side of the screw terminal. I would say that my left wire there, the insulation is maybe still a little long. I like to see about that 1 millimeter gap between the insulation and the screw terminal. But the main thing is that there's definitely no insulation inside the screw terminal, and there is definitely completely insulation out here where we have these strain relief teeth coming down on the cable like that, right? And so now we can see that between the teeth on the body and the teeth on the top here, and the 2 extra screws and the 2 screws from the bag that it comes with, I can now tighten this down, and it'll then be well strain relieved. Trying to get the screws dropped into the holes can sometimes be a little touchy, so I like to use a pair of tweezers. Come on, come on. To get it dropped into the hole. Come on. Well, sometimes it's just easier to start over and drop it in straight from the top. Yep, there we go. And then get the right size Phillips screwdriver to tighten these up. Oh, is it not? Come on. Just need to, it's a little bit, got to put a little bit of pressure on it to get it started in particular, since we now have so much between the insulation and everything. So again, we're looking for, you know, firmly finger tight, but don't over tighten, since we've got, there's a metal into plastic thread here. So we don't want to over tighten that, and we also don't want to crush the insulation here. But that is pretty dang firm. And so we'll want to do the same thing on the output. So come in, and this one's nice since we've got the neutral with the ribbing on it. If you weren't sure, you would then could take your multimeter to ohm out which side's your line and which side's your neutral. We're going to cut off the insulation that I nicked a little bit, separating those 2 webs. So we've got a nice piece there. Come back in with our wire strippers, real carefully remove about 8 millimeters of insulation material. And so what you'll notice, I'm scoring it all the way around, as I'm not depending on just being able to, like, right? Because I nominally, you could, you know, say, well, it's a round blade, so I could just, you know, crush the whole insulation with it and, you know, be done. And that's true. You could. I don't like to depend on that. I much prefer this kind of score it all the way around a little bit at a time until the point where it's just more than happy to break off and come off all on its own. So looking at that, it looks like this, one of my 2 sides is, again, a little bit too, I didn't strip quite enough on it. So I'm going to strip a little bit more. All right, so we're pushing our luck here. There we go. Yeah, so look at that. So we've got 2 very evenly stripped, relatively shortly stripped. We haven't adulterated any of the copper conductors themselves, since you really don't want to. And none of them are like splayed off randomly. So I'm going to put a slight twist on it just to make my job a little bit easier getting this into the screw terminal. And again, we're making sure that we got the right wires into your line and neutral. And I'm going to pre-form these wires a little bit so that the two of them aren't out like this, but really coming in very parallel, which will make my job a little bit easier trying to lace these 2 stranded wires into the two screw terminals. They've bottomed out nicely. So I'm going to tighten these two screw terminals. So again, since these are the kind of cheesy leaf, like kind of it's got a piece of metal that the screw is pushing down on screw terminals. These ones I prefer to put bare stranded wire into like this. When I'm using the much nicer and much bigger screw terminals where I've got space, I actually prefer to put wire ferrules on each of my stranded conductors. So this is literally, it's a crimp connector that is just a metal tube that essentially turns your stranded wire into, just on the tips, a solid piece of wire. And so this is kind of, it's like, you can kind of imagine this like the ends of your shoelaces. And this makes it really hard for your wires to fray. It does a little bit more strain relief. It gives you something really solid for your screw terminals to bite into. This is what the crimper for it looks like. And so you'll notice it's 4 sides that all kind of spiral in. And so it makes this into a very clean square shape. And I bought this whole kit on eBay for like, I think the tool plus the kit of ferrules was something like $25, right? And so for this sort of stuff, I really like ferrules, but these screw terminals are so small that I can't put ferrules onto the 16 gauge wire and then still have them fit into the screw terminals. So that's why we're not doing that. But I'm really happy with Sonoff's strain relief covers here with the little teeth on the insulation. So I'm not too concerned about it. Like this is actually, this is coming together much nicer than I originally imagined. And so I'm going to say that I still wouldn't endorse you building a switched extension cord like this if you had like small children or a lot of strangers around. But I'm pretty happy with how this is coming together. So get those 2 screws lined up. Oh, come on. Try and get those started. So that's it. So I mean, again, I wouldn't hang this with tension on there, but that is definitely finger safe, and it feels really good. So now, if I power this on, so this has the Tasmota firmware on it right now. So I mean, I could conceivably, from whatever my automation system is, control this, but also just with the front button here, we can see that I can still turn it on and off. But yeah, so I'm really impressed with these. I'm gonna certainly start playing with these since they're, it's very hacker friendly. It's less than $10 a piece on Amazon. You can buy them in packs of 1, 2, 4. You can, if you want to do your whole house in these things, they have bulk packages. But yeah, so I'm real impressed. I'm real happy with them. And so if you've played around with any of the Sonoff stuff as well, you can let me know in the comments. And other than that, thanks for watching. Enjoy.